4x equals 34. So x equals 34 divided by 4, which is 8.5 or 8.5. Right, Dan has some marbles. Let's call them D. Ellie has twice as many marbles as Dan, so Ellie has got 2 lots of D, and Frank has 15 marbles. Okay, if D plus E plus F, which is what they're saying, have got 63, let's have a look. That's D plus 2D plus 15 equals 63. So 3Ds, 3 lots of Dan's marbles, plus 15 equals 63. That must be 3D equals 63 minus 15. 3D equals 48. And 3 lots of 16 gives me 48. So Dan must have 16 marbles. Okay. Here are some patterns from white centimetre squares. So what's going on? So the white, pattern 1, pattern 2, pattern 3. Remember, this is when n equals 1, n equals 2, n equals 3. A pattern has 20 grey squares. We're looking at the grey, there's 2 there, there's 4 for number 2, there's 6 for number 3, so the grey is 2 times n. So if a pattern's got 20 grey squares, then n must have been 10. It must have been the 10th pattern. Right, work out how many white squares in the pattern. Looking at the pattern for the white squares, I've got 2 when n equals 1. I've got 3 when n equals 2. So white, when n equals 1, 2, 3, I've got white as 2, 3 and 4. So it must be the pattern number plus 1. So looking at the 10th pattern, I must have had 11 white squares because I must have had 10 plus 1, which is equal to 11. Okay, find an expression for the total number of centimetre squares in pattern n. If I look at them all together, can you see that this little one stands on its own on the end? So whatever the sequence is, I'm always adding 1 to it. So if I look, in total, I've got 3 squares plus 1 for pattern number 1. I've got 6 squares plus 1 for pattern 2. So that's 3n plus 1. Let's just try it out. 3 times 1 is 3, yeah, plus 1 is 4, yeah. 3 times 2 is 6, plus 1 is 7, yeah, there's 7 there. 3 times 3 for pattern 3, plus 1 is 9, plus 1 is 10 for pattern 3. So the expression is 3n plus 1. Okay, first 5 terms of an arithmetic sequence. That means it goes up in order. What does it go up in? 2s. So it must be the 2 times table, so it must be 2n. What would come here beforehand? What's 2 less than 3 is 1, so it must be 2n plus 1. Or comparing it with the 2 times table, 2, 4, 6, 8, it's not 2, it's 3. It's not 4, it's 5, so it's 2n plus 1. Again, another one. What's it going up with? It's going up in 4s, so it's the 4 times table. But it's not 4, it's 2. It's not 8, it's 6. It's minus 2. 4 times table minus 2. Or another way round is saying, well, what would come here? Okay, what's 4 less than 2? And it's minus 2. So again, that gives you 4n minus 2. Is 86 in the sequence? So you must give a reason. You can't just say yes or no. Well, let's try it out. It would work as a whole number if this works. Let's have a look. So 4n equals 86 plus 2, which is 88. And n is 88 divided by 4, and that is 22. So yes, it is. It's the 22nd term in the sequence. 13. Fibonacci. Fibonacci is when you add, so sum means add the two previous terms to find the next one. Find the ninth. Well, let's have a look. 1, 2, 3, 4, 5, 6. Right, 8 plus 5, 11. No, sorry, 13. So that is the 7th, 8th. 8 plus 13 is 21. And the ninth one, 13 plus 21 is 34. So 34 is the ninth term. The first three terms are A and B, A plus B. Show that the sixth term of the sequence is 3A plus 5B. Let's have a look. 1, 2, 3, 4. So 4 is going to be A plus 2B, because I'm going to do 2 and 3. 5 is going to be A plus A, which is 2A, and B plus 2B, which is 3B. And 6 is going to be 5 and 4 added together, so 2A add A is 3A, 3B add 2B is 5B. You have to show how you've worked it out. Okay, given that the third term is 7, right, let's have a look back. So that means A plus B equals 7. And the sixth term, that's 3A plus 5B equals 29. Okay, find the value of A and the value of B. There's different ways of doing this. You could sort of do it by trial and error. So you could just literally think, well, A plus B must be equal to 7 and try different things out. Okay, well, I know 3 and 4 makes 7, but it could be 2 and 5, and it could be 1 and 6. So you could do it that way. Or another way would be, say, like, rearrange this and say, so A must be 7 minus B. And I could put it in here, 7 minus B plus 5B equals 29. And then I've just got B's. So 3 7s are 21 minus 3B plus 5B equals 29. So 21 plus 2B equals 29. That means 2B is 29 minus 21, which is just 8. So B equals 4. And then going back into that, if A plus B equals 7, A must be equal to 3, because 3 add 4 makes 7. First 5 terms of an arithmetic sequence, what does it go up in? It goes up in 4s, so it must be 4n. Okay, but it's not the 4 times table. Well, it's the 4 times table. Let's have a look. 4, 8, 12. The 4 times table minus 3. Or thinking about what would come here, 4 less than 1 is minus 3. The nth term of a different sequence is 3n squared plus 7. Find the 10th term. Be really careful that you use BIDMAS. You have to do 3 times 10 squared plus 7. And 10 squared is 100 plus 7. So it's 300 plus 7. So the answer is 307. Okay, so now do your corrections of the ones that you got wrong on test 2B, which is